Alright, welcome once more to our discussion on data and SQL. All along, we have been talking about traditional databases. This time around, we will go above and beyond into NoSQL databases. But why? Traditional databases have some key limitations like scalability, rigid schema, and inability to handle diverse data types. That is where NoSQL databases come in. NoSQL, or not only SQL databases, were developed to address these limitations, and they provide flexibility, scalability, and performance for modern applications. Unlike traditional SQL databases, with their structured tables and rows, NoSQL databases use various data models to store data. For instance, document databases like MongoDB, which is an open-source database management system that stores data in flat files, think of JSON-like documents, provides a very flexible schema which is good for semi-structured data. Also, key value stores like Redis, which stands for Remote Dictionary Server, is a very popular NoSQL database with an easy-to-use interface and many clients to integrate with an application. They provide fast lookups, which is very good for caching and session management. Also, we have column family stores like Cassandra, which stores the data in columns that are grouped into families. They are very scalable and good for huge data sets. Finally, we have graph databases like Neo4j, which is an ACID-compliant NoSQL database. It uses proprietary data models to store and represent data, focusing on relationships between data points. Very good for social networks and recommendation engines. When it comes to basic CRUD operations to create, read, update, and delete data in NoSQL databases, they often have their own query languages or use a flexible approach like JSON-based queries. Yet, they also do have indexing, filtering, and sorting based on specific fields, as well as limiting and skipping results. Advanced operations can also be performed like aggregation, text search, geospatial queries, and so on. To be specific, MongoDB has MongoDB Query Language, or MQL, to query and manipulate data. Key value stores also have similar uses with key value operations. Wide column stores use Cassandra Query Language for querying and manipulating data, while graph databases like Neo4j use Cypher Query Language to traverse relationships between the nodes and the edges. It is worthy to note that the specific syntax and capabilities may vary depending on the NoSQL database you're using, but it's imperative to consult the documentation of your chosen NoSQL database for detailed instructions and examples. NoSQL's flexibility, scalability, and performance make it crucial for many industries to provide seamless and engaging experiences to billions of users worldwide. For instance, PayPal, which is a financial institution, uses Apache Kafka and Cassandra to process massive streams of payment data to detect fraud in real time, while Barclays uses MongoDB to manage risk across various asset classes And Capital One also uses NoSQL to provide customized financial advice and product recommendations to its customers. Meanwhile, Cleveland Clinic in Healthcare uses MongoDB to manage its electronic health record system, providing clinicians with quick access to patient information. And the National Institute of Health, NIH, uses NoSQL to store and analyze genomic data for various research projects. In sports though, even the NBA uses NoSQL to track player movements and analyze game statistics, while ESPN uses NoSQL to deliver personalized sports news and updates to its users. But that's not all. Big tech companies are also heavily involved, with Facebook using Cassandra to handle enormous volumes of data and user interactions like posts and messages, while Google employs Bigtable to power applications like personalized search results and maps. Amazon on its own created DynamoDB, which stores and manages customer profiles, shopping carts, order history, and so on and so forth, used in e-commerce platforms. Instagram, with its focus on images and videos, uses NoSQL databases like Cassandra to store and deliver media content efficiently to its vast user base, while Microsoft created Azure Cosmos DB, which enables real-time features in applications like gaming leaderboards, chat applications with a low latency across its entire ecosystem. Finally, NoSQL databases and AI have a synergistic relationship, with NoSQL often serving as the foundation for developing and deploying AI applications. We can look into this in our future videos. To round up, databases, be it SQL or NoSQL, could either reside on premises or on the cloud. Also, they could either be open source or proprietary. Better yet, we also have multi-model solutions that can accept both structured and semi-structured with unstructured data, such as Cosmos DB from Microsoft. But for a small scale, it is worthy to note that SQLite is very useful. SQLite on its own is a lightweight and self-contained, serverless relational database model. It is very easy to embed in applications and good for mobile apps and embedded systems. We can also take a look at the ranking of all databases across the board using the dbengines.com ranking. Thank you for watching this video. Kindly like and share with others. Don't forget to subscribe to my channel for more videos. This is Vitus DK. You already know.